Hi, I'm Brian Wright. I'm the director of the undergraduate program. I'm the Quantitative Foundation Associate Professor of Data Science. I think everything that we've seen over the last 2 years in this just rapid development and integration of AI into every aspect of our lives, that data science is 100% going to be like the wave of the future. It's going to be integrated into our economy from the very lowest level all the way up to the C-suite. And it's just going to become just a necessary skill. Our vision when we first created the undergraduate program was to make it essentially a liberal arts degree for the data age. I mean, I am a big believer that all these skills should really be taught in the undergraduate as a core 21st century data literacy degree. Our vision was to communicate a big tent, to attract a large cross-section of students that are interested in this growing and in-demand field. We like to think that, every student can be successful. We know that every student comes from different places, and we've designed the degree to be a 3-year degree so that the students that come in that need a bit more of an on-ramp into the mathematical concepts have plenty of space to do that. Everything we do, everything we build is designed around student success. We wouldn't do it, we wouldn't implement it if we didn't think it was best for the students. The 4+1 model is our conceptual framework for what data science is. It includes these 4 pieces. It's analytics, which is everything from machine learning to AI to the applications of these analytical models and statistics. Value is another component of it, which we think like what happens when these models and these data science products go into the world. That can include business value as it relates to profit and margin, but as well as human value, like what value are they giving to society. We have design. Design is everything from database design to kind of data visualizations. It's kind of like the manifestation of how these models don't just exist in code, but how do they come to life in the real world. And the last one is systems. Systems is everything when we think of from coding to engineering to cloud-based systems, databases, right? When they all come together, it forms the +1, which is the applied part when all those components come together and form a data science product. The Bachelor of Science of Data Science starts out your second year at UVA. The first year is just 2 prerequisites, just a programming course and a Foundations of Data Science course. The idea behind that class is not to eliminate students, but to say, hey, is data science right for me? Once students are admitted into the degree, which happens after their first year, the first year in the degree, which is the second year at UVA, is really about setting like core foundational skills. So in that first semester, you're going to get computational probability. You're going to take Systems 1, which is an engineering and database class. And if you need to, you'll take Calculus 1 if you haven't taken that yet. And also our first kind of communications course, which is called Communicating with Data. The second semester, we kind of move into more of the analytical methods where you take Machine Learning 1 and Mathematics of Data Science, which is a nice pair to that class. So you're using the applied methods, but also understanding what goes on underneath the hood as it relates to the mathematical theories behind these mathematical concepts. That semester, you also get exposed to Data and Society 1, and it talks about data regulations and policy and the constraints and realities associated with deploying data science products into the marketplace. The second year of the core sees students taking 2 classes. So this is going to be our Machine Learning 2 class and then our Systems 2 class. So both those are pretty advanced. And then the final semester of the core, students are going to take our second data design class, which is called Data by Design, which teaches them about experimental design and how to represent data in different data pipelines. They're going to take the second Data and Society class, which is interpretive methods, right? It's called Explainable AI. So not only do you understand data policy and governance, but you'll also be exposed to deep learning methods or other machine learning techniques actually optimized so you can get underneath the hood and understand how they work, which is a huge important part of understanding how they're going to impact people when they're put out into the world. And the last class in that semester is called Prediction and Inference. This class is going to be focused a bit more on causation, all right? Kind of more experimental design and pick up a lot of the methods that are really important for data science. And at the end of that, there are almost no required courses in your 4th year. Well, that 4th year is really just a blank slate. So we're going to give you this core set of intense data science skills. And then it's like, hey, where do I want to go from there? It's your choice. We have a group of concentrations inside the School of Data Science, but also externally and partners from everything from neuroscience to economics and public policy. So there's a lot of pathways for students after they go through kind of our core set of undergraduate degree. Then they venture out and can explore other topics that they'd be interested in across the university. So And then the last class students take that's required from us is the project course, which comes at the very last semester. The final project is designed to be exactly that, like an application of all the things they've learned over the last 2.5 years inside the degree. The idea is that's supposed to be an end-to-end data science product, everything from data acquisition to data organization and systems, and then they're supposed to deploy machine learning algorithm and then actively track its results, so end-to-end, which is a big thing that data science programs, I think, around the country are actually pretty weak in, is bringing final data science products to production. It's a huge advantage for our program in particular. We designed a degree to fit a wide variety of backgrounds. So we're going to give you this core set of intense data science skills. And then it's like, hey, where do I want to go from there? It's your choice. So we assume there'll be dozens of different degree combinations and concentration options that students choose. And that's what we want. Like I said, there's not one degree for everyone. There's a whole bunch of different options. And at the end of the day, we hope students choose a variety of them based off whatever their interest areas are. I think the future is great for data science, and it really aligns with what we think of jobs of the future. If you want to learn more about the School of Data Science and the Bachelor of Science in Data Science, please reach out to me. I think everybody can find a place here, and we'd love to have a conversation with you about it.